हेलो बच्चों, हाउ आर यू। आप सब कैसे हैं। उम्मीद है आप लोग सब अच्छे होंगे और मन लगाकर पढ़ाई कर रहे होंगे। मैं आप लोगों के लिए एक नया वीडियो लेकर आया हूं जो कि मैथमेटिक्स से रिलेटेड है। इस वीडियो लेक्चर में हम लोग नंबर सिस्टम के बारे में पढ़ेंगे। दिस टॉपिक्स बिलोंग टू क्लास 9th and this is chapter number 1. So under this chapter we will study about the number systems. So what is number and how we represent number on the number line, we will study about this. So for that you can see on the screen we represent the number on the number line, and this is a number line, and there is a reference point. We denote this reference point as 0, and we can move on either side from 0 to plus side and 0 to minus side, right? Now just imagine that you start from 0 and go walking along this number in the positive direction. So as you move in the positive direction, there are numbers and infinite numbers. So these infinite numbers are of different types. Some are integers, some are rational, some are irrational, some are whole numbers, and so on. So we will study about those numbers in this chapter and how we can represent those numbers on the line. We will study those things. So let's start the video lecture. Myself Virendra Kumar, professor and scientist, and you are watching the Sciacademy channel. So बच्चों, let's move. So as we move along the number line, we want to collect some numbers. For that, let's take a bag and we will store these numbers one by one. So firstly, we'll study about the natural numbers. What are those numbers? Natural numbers starts from 1 and it goes on 1, 2, 3, 4, 5, 6 and so on up to the infinity. So these numbers are called natural numbers, and we denote these numbers by symbol capital N. So you can see here in this bag that these numbers are denoted by capital N bag, and in this bag 1, 2, 3, there are so numbers from 1 to infinity. So these numbers are called natural numbers. So I hope that you understand what is natural number. So natural number starts from 1 and goes on up to infinity. Now we just left a number 0. Now we want to take it also 0. Then the number system will be known as whole numbers. So these whole numbers, that means the symbol W is denoted for the whole numbers, and whole numbers include 0 with natural numbers like 1, 2, 3 and 4, so on. So if we include 0, then the numbers is known as whole numbers. So you can see in this picture that we are including 0 along with natural number, and then it becomes whole number. So mind it, whole number include 0. Now in front of you there are many negative integers. So all negative integers will collect, and these are known as the integers. So that means if you are collecting 0, 1, 2, 3 and so on up to the infinity and going back on the natural line number number lines and collecting the negative number also, -1, -2, -3 and so on in the left side, then it makes the integer. Okay, so that integer is denoted by the symbol capital Z. So you can see here in this bag numbers are 0, 1, 2, 3, 4, 5 up to infinity, also containing numbers -1, -2, -3 and so on. So now we all have the integers, that means 0, 1, 2, 3 as well as the negative numbers -1, -2, -3 all. So that collectively are called the integers. Now we'll talk about the rational numbers. So what are those numbers? Let's see. If we are having numbers like this or this, then these type of numbers are called rational numbers. That means if we can represent these numbers in the ratio format p by q, where q is not equal to 0 and p and q are integers, then these are called rational numbers and it is denoted by the symbol capital Q. So up to till now we collected in the bag natural numbers, whole numbers, integers, okay, and now the rational numbers. So for integer there was Z sign and for the rational number this is Q. So rational number are those numbers that can be written in the form of p by q, where q is not equal to 0. But why we are taking q not equal to 0? What happens if we take q is equal to 0? So that time if we are keeping q is equal to 0, that time number will be make the infinity. If you are dividing any number by 0, that will make the infinity. So in that time this will be not a rational number. Okay, notice that all numbers now in the bag can be written in the form of p by q, where p and q are integers, emphasizing q is not equal to 0. Now take for example -25, and if you are and this -25 can be written as this -25 divided by 1. Here p is equal to -25 and q is equal to 1. Therefore rational numbers also include the natural numbers. That means all the natural numbers are rational numbers, because any natural numbers can be written in the form of this divided by the number 1. So naturally all the natural numbers are rational numbers. Now take the example 1 by 2. So these 1 by 2 can be written as 2 by 4, 10 by 20, 25 by 50. That means and so on. That means any rational numbers can be written in terms of its equivalent, and these are known as the equivalent rational numbers, or sometimes called the fractions. However, when we say that p by q is a rational number, or when we represent p by q on the number line, we assume that q is not equal to 0, correct? And that p and q have no common factors other than 1. So that means here p by q is the rational number, and p and q are the co-prime. That means p and q don't have any common factors except 1. That's why they are co-prime. So any rational number can be written in terms of p by q, where p and q must be co-prime to each other. So here there is example, and you can solve this example because solution is given. So I will move further. Here there are infinitely many rational numbers between any two given rational numbers, correct? So suppose if you are taking two numbers 2 and 3, 2 by 1 and 3 by 1, because any natural numbers can be rational numbers. So if we are taking 2 and 3, 2 by 1 and 3 by 1 are rational numbers, definitely there are others number in between the two numbers, and that numbers are infinite in quantity. That means if you are picking any two closed rational numbers, then there is a possibility that there are infinite rational numbers in between the two chosen numbers. Now we will think about the other number, that is irrational number. So what is irrational number? So we will study about the irrational numbers. In the previous section, we saw that there may be numbers on the number line that are not rationals. In this section, we are going to investigate these numbers that is not rational number, and that numbers are known as the irrational numbers. So we know that rational numbers can be represented in the form of p by q, here p and q are integers and q is not equal to 0. So you know integers, all numbers including negative and 0 and positive, total numbers are integers. Certainly there are numbers which are not of the form p by q, and those numbers are the irrational numbers. For example, square root 2 is irrational number, square root 3 is irrational number, and square root 5 is irrational numbers, and pi is irrational number. So there are many irrational numbers. It cannot be written in the form of p by q. So irrational numbers cannot be represented as the ratio form. So we up to now learned about the natural numbers, integers, whole numbers, rational numbers, and now we are learning about the irrational numbers. So irrational numbers which cannot be written in the form of p by q, where p and q are integers and q is not equal to 0, then the number is called the irrational number. So I told you that there are many numbers which cannot be written in the form of p by q, and those are square root 2, square root 3, square root 15, pi, and so on. So बच्चों, we have studied till now about the irrational numbers, and we are putting the irrational number in terms of this radical sign. And so if you are taking this square root 4, there are two roots, plus and minus, but in the case of irrational numbers we are talking about the positive value only. So caution is that you should take the positive value always, right? So some of the irrational numbers listed above are familiar to you. There is a number that is called the pi. So pi is very well known irrational numbers, and there are many research over the pi. When we are taking rational and irrational number together, then that number is called the real number, right? So real number is those numbers which are rational and irrational. So these two numbers are real numbers, whether it is rational or irrational. So therefore a real number is either rational number or irrational number. We can say that every real number is represented by a unique point on the number line, and also every point on the number line represents a unique real number. That means on real number line, every point on the number line represents a real number. That may be rational or irrational, correct? Now take an example. Locate square root 2 on the number line. How can you do that? To locate this number square root 2 on number line, we just use the Pythagoras theorem. That just see, we will take this as a 1 unit and this 1 unit, and then by using the square root, by using the Pythagoras theorem, this diagonal will be square root 2, but we want to represent this OB on the real number line. For that, what we will do, that we will consider a square OABC, and then transfer onto the number line by using the vertex O coinciding with 0. And by using a compass with center O and radius OB, we draw an arc from B to P on this real number line, and where it cut, that OP represents the value of square root 2. Similarly, we can locate the square root 3 on the number line, and so on. So by continuing this process, we will get the spiral number, and that is called the square root spiral. So you can construct this square root spiral by continuing this process, 1 square root 2 and then again 1, and this will give square root 3 and so on. Now we will study about the real numbers and their decimal expansions. That means, can we expand the real number into decimals and irrational numbers into decimals? We will study about those things. So you know that real numbers, rational numbers can be represented by p by q, where p and q are integers and q is not equal to 0. So take this example, 10 by 3, 7 by 8, 1 by 7. So 1 by 1 we will see that how much the value comes out in terms of the decimal. So let us divide 10 by 3. So by dividing we get this value, and for 7 by 8 it gives 0.875, and for 1 by 7 it gives this value. So in these examples we see that either remainder comes out 1, 0 or 1. That means either division is complete or coming out some remainder. So it should be noticed that the remainders either become 0 after a certain stage or starts repeating themselves. The number of entries in the repeating string of remainders is less than the divisor. If the remainder repeats, then we get a repeating block of digits in the quotient. For example, in the case of 10 by 3, 3 repeats in the quotient, and for 1 by 7 we get repeating block. That means this much value gets repeated after one another. What does it mean? It means that after dividing the after getting the decimal expression for the rational number, we will get the quotient in terms of terminating or non-terminating values. So we will see those things. So let us consider the case number 1. If the remainder becomes 0, so what will happen? In the case of 7 by 8, we found that remainder becomes 0. That means completely division, and we'll get the quotient 0.875. So there is no repetition. Final result terminate the steps. Also we can see this type of examples in case of 1 by 2, 639 divided by 250. So these are the complete results. There is no repetition, there is no recurrence, and this type of decimal expansion is called terminating. And now we'll take the case of the remainder never becomes 0. For example, in the case of 10 by 3 and 1 by 7, we saw that the remainder repeats after a certain stage, forcing the decimal expansion to go on forever when there is no ending. If you divide 10 by 3, you will get 3.33333333. It will go on up to infinite. Similarly, when you divide 1 by 7, you will get this value 0.142857, and again 142,857, and again 142,857. That means there is a repetition of a certain numbers. That means this is called block, repeating block. So what we will do to represent in the short, we will use the bar. If the digit is repeating itself again and again, then what we will do, we will put some bar over the repeating digits. If it is block, that means a combined number of digit, then you will do, you will put bar over the whole block, like in the case of 142,857. Similarly, if you take this example and 57272, that means 72 is repeating, so we will put the bar over the digits. And all these example gives us non-terminating recurring, that means repeating decimal expansions. Correct? Now suppose on your walk on the number lines, real number lines, you know why we call it real number? Because every point on the number line gives the real number, whether it is rational or irrational. So you come across a number like 3.142678, whose decimal expansion is terminating, or a number like 1.272727, that is whose decimal expansion is non-terminating recurring. So can you say that it is real, it is rational or irrational? Yes, this is rational. Why? Because it is terminating and it is not terminating. So both cases may be there, terminating or non-terminating. So this is the point, that decimal expansion of rational numbers have only two choices, either they are terminating or non-terminating. Note it, both can be possible, either they are terminating or non-terminating. So if you want to write back, that means from decimal expansion to the rational number, how can you do that? So there is a certain way to find back the rational number in terms of the ratio p by q, where q is not equal to 0 and p and q are integers. Correct? So for that, what you will do, let us take an example. So if you are taking 3.142678 and you want to get back the ratio format, so what you will do, we will count the number of digits after the decimal point. So here there are 6 digits. So what you will do, that we will write this complete value and divide by using 1 after 6 digits, 60 digits, that means, and you will get the rational number. Similarly, what you will do, if the example is this type 0.333, and that means there is repetition of the 3 value, so what you will do, you can do this by a certain trick. Let us solve this example. So you have to find the ratio format of this value. So what you will do, you will assume that let x is this value, therefore you can write that 10x is equal to 10 times this value, that means this will come out 3.33, that means this is equal to this 3 plus 0.333, and this is nothing but x, that means it comes out 3 plus x. So 10x is equal to 3 plus x, that means 9x is equal to 3, that means x is equal to 1 by 3, that means you get the number, rational number in terms of the p by q format. So that is the way to get the number back in terms of the ratio. Correct? Similarly, if you are asked for getting the ratio format of this type, means that is here the block is repeating, 27 is repeating. So how you can do that? So you will do by using the 2 digits by multiplying the 100. In earlier case, when the 1 digit was repeating, you multiplied by 10. Now 2 digits are repeating, so you will multiply by 100. That means if you assume that x is the number 1.272727 and 27 is repeating, so we will take 100x. So 100x, that means we will multiply this value by 100, so we will get 127.272727, and that is nothing but 126 plus this value, that means 126 plus x. So you will solve this for x. So x will come out as 126 divided by 99, that means 14 by 11. What we will do, we will divide both numerator and denominator by 9. So ultimately we get the format of p by q ratio. So now there is another kind of example. How can you get this if there is repeating block after a certain digit? So in that case, what you will do, that here the 2 doesn't repeat, but the block 3 5 is repeating. So in that case, we multiply this by 100, so we'll get to 3.5353. So 100x is equal to 23.3. That means our ultimate goal is to find the original number. So what you will do, the number what you get will minus the original number, and that remainder we will put here, and then ultimately you will get the original number. And then you can solve this for the x. I think you got the point. इफ़ बच्चों आप लोगों को कोई दिक्कत हो, कोई क्वेरी हो, कोई डाउट्स हो, तो आप जो है कमेंट बॉक्स में हमसे पूछ लीजिए. प्लीज़ आस्क मी इफ़ देयर इज एनी डाउट्स, क्वेरी. आई विल रिस्पॉन्ड यू एज सुन एज पॉसिबल. ओके. So we get that every number with non-terminating recurring decimal expansion can be expressed in the form of p by q. Let us summarize our results. So we want to conclude that the decimal expansion of rational number is either terminating or non-terminating. Correct? A number whose decimal expansion is terminating or non-terminating recurring is rational. Correct? So now we know what the decimal expansion of rational number can be. What about the decimal expansion of irrational numbers? Now we will find how the irrational number can be expressed in terms of the decimal. So because of the property above what we found, we conclude that their decimal expansion are non-terminating, non-recurring. So for irrational numbers, when we express in terms of the decimal, so the decimal expressions come out as non-terminating, non-recurring. That means they are non-terminating, never ending, but they are also non-repeating, non-recurring. That means every time you are getting the different digits, there is no pattern of repetition in terms of the irrational number. For example, pi. So if you expand pi in terms of decimal, so you will get infinite number of digits after decimal, and that is non-terminating and non-recurring also. That means there is no repetition of the certain pattern. Okay, so the property for irrational numbers, similar to the property stated above for rational numbers, is the decimal expansion of irrational number is non-terminating, non-recurring, and a number whose decimal expansion is non-terminating, non-recurring is irrational. Right? Now recall this number. We talked about this number earlier. So notice that it is non-terminating and non-recurring. There is no repetition. There is no certain pattern which repeats. Therefore, from the property above, it is irrational, and we notice that you can generate infinitely many irrational numbers similar to this number. Similarly, square root 2, there is no certain pattern of repetition. Every time you are getting the different digit. Of course, you are getting the digits in between among the 0 to 9, but there is no certain pattern of repetition. That means in irrationals, the number is non-terminating. There is no ending of the number after decimal, and they never repeat in a certain pattern. There is no repetition. And second example is pi. Generally we write pi is equal to 22/7, but that is not perfectly equal. That is the approximate value for pi, right? So there is a history of evaluation of pi. Now example number 10, find an irrational number between 1/7 and 2/7. So if you are asked to find a number in between the two, and that number is irrational, so how can you find that? For that you have to calculate their decimal value. So first we will convert this number from ratio to decimal, and here also we see that the number lying between these two will be more than 0.142857. That means if you write 0.15 and less than that this value, that number will be existing between the two. So similarly, that means this may be the one of the infinite number of irrational numbers between the given irrational numbers, right? So there is exercise 1.3. You practice it. If you found any difficulties, so please inform me through comments. I will try to solve your problems. Now representing real numbers on the real number line. How can you represent the real numbers on the number lines? So there is a trick here. You can represent the real numbers, then that means the rational and irrational, any number of the real number, it may be the rational or irrational, and you have to represent that number on the number line. So rational numbers, you know, there is a decimal points, and that is non repeating or non repeating, and terminating and non terminating. That means it is very difficult to represent the decimal values on the number line, but you can represent by magnifying the line every time. Suppose you have to find the value of 2.665. so firstly what you will do, that you will check it whether it is lying where it is lying. So definitely this value is lying between 2 and 3. So firstly what you will do, that you will divide the two line between 2 and 3 into 10 points, and then you will try to reach to close to the 2.6. Firstly we will find out the in between the 2 and 3 2.5, and then you will magnify again and you will find the 2.6, and then you will approach towards the closeness of this number. So in this way, by magnifying the number, you can represent the real number on the real number line, correct? So this is the way of representing the real numbers on the real number line. Now operations on real numbers. what type of operation, mathematical operation you can perform with the real numbers. So real number is a very useful, it is very important in mathematics, it is useful in physics, it is useful in chemistry, everywhere you will get it. This is very important. So that's why I wanted to discuss, because very many students get confused with this concept that irrational and irrational numbers, and if you uh, get understand these things, it will not never confuse with the concept. So here the rational numbers satisfied the commutative, associative and distributive laws for addition and multiplications. You know this. If we add, subtract, multiply or divide two rational numbers, we get again the rational numbers except 0. Correct? So that is, rational numbers are closed with respect to addition, subtraction, multiplication and division. So if you are multiplying, dividing, addition, subtraction between two rational numbers, the result will be always rational numbers. That means the rational numbers are closed with respect to these operations. But irrational numbers is not. In case of irrational number, the result is different. May be same. Correct? So if rational numbers, irrational numbers also satisfy the commutative, associative and distributive laws for addition and multiplication, but the sum, difference, quotients and the products of irrational numbers are not always irrational. So the distribution and association commutative properties are followed in case of the irrational numbers, but the direct sum, addition, difference, division are not always the same number. It may be same, it may not be. So for example, if you are adding the two irrational numbers like square root 6 and minus square root 6 and square root 2 minus square root 2, so are rational, it becomes rational because this will give 0 and this will also give 0 and this will give the 3, this will give 1. So we will get the rational numbers, not the irrational. Are you getting? Now let us look at what happens when we add and multiply a rational number with an irrational number. That means cross product. One number is rational and another number is irrational, and we want to multiply. So what will be the result? Now let us take square root 3 is irrational number and you want to add rational number 2. So the result will be 2 plus square root 3. That will be irrational, and multiplication is also irrational. Since square root 3 has non-terminating and non-recurring decimal expansion, the same is true for 2 plus square root 3, and that means the result will be always irrational in this case. Therefore, plus 2 plus 2 square root 3 and 2 into square root 3 are irrational numbers. Now check whether 7 into square root 5, 7 by square root 5, 2 square root 2 plus 21, pi minus 2 are rational or irrational. So what we will do, you know that square root 5 value is 2.236 and square root 2 is 1.4142, pi is equal to 3.1515. So using this you can get 7 into square root 5, multiply the value of square root 5 into 7, you will get this. Similarly you get this, by simplification it will give this and this and so on. So all these are non-terminating, non-recurring decimals. That means all these numbers are irrational numbers. So property of irrational number is that the decimal digits should not be ending it is continuous, non-terminating, and numbers are also not repeating, non-recurring. So in this case there is no repetition, there is no ending, so these are irrational numbers. Now question is add this and this. How will do that? You can do that by this. Bring the same type of digits together and take the common out, and you will get in terms of the irrational numbers. So what is the meaning of simplification? So actually when you want to add the two irrational numbers, the result should be in terms of the irrational numbers or rational numbers. That is the main purpose. So these are some facts, the following facts which are true. Sum or difference of a rational number and irrational number is irrational number. So if you do this addition or subtraction of rational and irrational, so number is always coming out the irrational number, right? The product or quotient of a non-zero rational number with irrational number is irrational number. आप चाहें मल्टीप्लाई करें या आप डिवाइड करें रेशनल नंबर का इरेशनल के नंबर के साथ, तो रिजल्ट का हमेशा जो है इरेशनल नंबर आएगा. इफ़ यू एड, subtract, multiply or divide two irrational numbers, the result may be rational or irrational. So in this case anything can happen, rational or irrational. Now we want to take square root of real numbers. So you know that square root a is equal to b, then this can be written as b square a, and b where b is greater than 0. The same definition can be extended for positive real numbers also. This is if a is a rational number, then this can be true, and this property is also true for the real numbers, rational or irrationals. So let a is greater than 0 be a real number, then square root a is equal to b means b square is equal to a and b is greater than 0. That means if a is greater than 0, then square root of this number is also more than 0. Also we have learned that square root of any integers can be represented on the number lines, right? So we now show how to find square root for any given real number. So previously we saw that we can represent the square root of any integers. Now if you are asked how to represent the square root of real number, or even if you are asked to represent on number line a rational or irrational number, then how can you represent? So we can represent by this. Let us learn this. If you want to find the square root of 3.5, so how can you represent this geometrically? For that, what we will do, that on number line we will draw this value 3.5 and we add 1 unit BC, and then we will take half of this value. Firstly we will draw this much value and then add 1, and after that we take half of this and we will put the 0 value there. Origin, you can say this as the center. And now Mark the distance 3 point unit from fixed point A on a given line to obtain B such that AB is equal to 3.5, and mark a distance 1 unit and new point is C. Find the midpoint of AC and mark the point A as the center, and we draw semicircle. So we draw the semicircle by taking the radius equal to AO or OC. So we'll draw this semicircle, and we'll draw perpendicular from point B to this semicircle, and it cuts, suppose it cuts at D, right? That value VD will represent this square root 3.5. So the steps are what? Firstly, we'll draw the value equal to the asked value, and then we add 1. After that, we divide this into half, and we will put the center there, and we draw semicircle by using the radius equal to half value, and after that we will draw perpendicular from the point B on the semicircle, and that value will give this value. This value will give the value of square root of the asked value, that means here 3.5. Similarly, you can find the square root of any real number by adopting this procedure, right? What is the fundamentals behind this? Let us evaluate. How can we say that this is correct? This geometrical method is correct. So we'll see that triangle OBD is a right angle triangle, this, and OB is equal to this. The radius of the circle is x plus 1 by 2. First we add x plus 1 and then we divide the x plus 1 by 2 is the radius. So and OC is OD, all are equal to half of this value, that means equal to the radius. Now OB you can calculate by subtracting total value x minus half of the x plus 1, that means you will get OB is equal to x minus 1 by 2. Are you getting? So that means OB is equal to x minus 1 by 2, and this, but you can calculate by using the Pythagoras theorem. BD square is equal to OD square minus OB square, and you will get x. Therefore BD is equal to square root x. That means what we are doing geometrically is correct. That is verified, right? Similarly, you can calculate the value of square root of any real numbers by geometry. This shows that square root x exists for all real numbers that is more than the 0. If you want to know the position of x on the number line, so here we get the value of the square root of the real numbers. Now if you want to represent that number on the real number line, how can you do that? We can do that by adopting this method. So method is, let us treat the line BC as the number line. So we draw this as a number line with B as 0, B is at 0 point, and C is 1. That means this is 1, this is 2, and so on. Now we draw a arc with center B and radius BD. So firstly what we did, that we find the value of square root x by geometry. So we get the BD value, that is square root x. Now by taking this B as the center, we draw an arc on the real number line, and that arc will cut at point E, right? So it is cutting at point E. So this is the real number line. So this value E will give the geometrical representation. That means on real number line we get the value on the real number, right? Now what is this symbol is known as the radical sign, right? So you know that cube root, square root, we used to know, we used to calculate. How can you calculate the cube root of 8? That comes out 2, and so on. So what is the significance of this radical sign with n inside this a real number, and n is the positive integer? So what is the meaning of this? So that can be written in terms of like this format. The remaining now, for any real numbers x and y, we can write x plus y into x minus y is equal to x square minus y square, and by this we can simplify the real numbers. So there are certain rules. Square root ab is equal to square root a into square root b, and square root of a by b is equal to square root a divided by square root b, and so on. And you will get this by using the formula a square minus b square. So x plus y into x minus y is equal to x square minus y square. So by using this formula we get this. Similarly we get this value, and we can simplify by using this formula. So this is very useful in terms of the real numbers. We can simplify these things. Try to solve this. If you are getting some difficulty, any difficulty, please let me know, provide your comment, and I will solve your problem. ठीक है बच्चों? So example number 17. So it is asking that rationalize the denominator of 1 by square root 2. So this numerator is 1 and denominator is square root 2. So it is asked to rationalize. That means simplify. So what you will do? Multiply both numerator and denominator by square root 2. So you will get this as a rational. So here, see, if you multiply both by square root 2 and square root 2, then this will give 2, and you will get this value, right? So half of the square root 2, that is rationalized. So denominator is rationalized. That is asked now. You have to rationalize the denominator. So this denominator is rationalized by multiplying the both numerator and denominator by square root 2. So this square root 2 into square root 2 gives the rational number 2. So square root 2 by 2, half of the square root 2, right? Similarly, it is asked to rationalize the 1 by 2 plus square root 3. So what you will do? You will multiply numerator and denominator by 2 minus square root 3. Because of the formula x square minus y square, the denominator will be rationalized like this. You will get this number. You will get this, then that value will come out. Similarly, you can rationalize this denominator, can be rationalized by adopting the same procedure. When here is a negative sign, you will multiply with opposite plus sign. If you are given here positive sign, then you will multiply with the opposite negative sign, and ultimately you will get the rational number in the denominator. ठीक है? So solve this exercise 1.5, and if you are getting any difficulties, let me know. So these are the rules for exponents for real numbers. That means if x to the power a into y to the power b is given, where x and y are real numbers, then you can get, this can be written as x y to the power a into b. Here if x to the power a into x to the power b, then the exponents will be added, a plus b. So you can solve it. This is very simple. And here if you are given like this, numerator by denominator, then what you have to do is that bring the denominator into numerator. How? 23 to the power 10 by 23 to the power 7. If you bring the denominator into the numerator, then 23 into 10 into multiply 23 minus 7, and then you will get 23 to the power 10 minus 7, that is 23 to the power 3. So you will get the result here. So similarly you can do for another. Try to solve it. I will help if you are getting any problem, difficulties, and inform me. So these are the some formula, you should remember this. And this is here the trick. What is a to the power 0? A to the power 0 always gives 1. It is 1. Remember this. I have already told you this. Use this concept. I will remember this. Right. So these are the things. Let us summarize the chapter. In this chapter, what you learnt? You have studied the following points. First, a number r is called a rational number if it is represented in terms of in form p by q, where q is not equal to 0 and p and q are integers. A number s is called irrational number if it cannot be written in the form of p by q, then it will be irrational number. If it is written in form of p by q, then it cannot be irrational. The decimal expansion of a rational number is either terminating or non-terminating. However, a number whose decimal expansion is terminating or not terminating recurring is rational. The decimal expansion of irrational number is non-terminating, non-recurring. So never ending and never repeating. That is then irrational number. All the rational and irrational numbers make up the collection of real numbers. Real numbers means rational plus irrational, or any rational or irrational are called the real numbers. That's why number line is called the real number line. There is a unique real number corresponding to every point on the number line. Also corresponding to each real number, there is a unique point on the number line. For each point on the number line, there is a corresponding real number, rational or irrational. If r is rational and s is irrational, then summation or subtraction are always irrational numbers. Rational. For positive real numbers a and b, the following identities hold. So remember this. This also. These are the some results. You should memorize this and understand how it is working. So bachon, these are the things which I wanted to discuss in this chapter on the number system. I hope that you understand the chapter. If you are getting any difficulties or any query you have, please inbox me, comment me, and I will try to find solve your problems. And students, if you have not subscribed the Sciacademy channel, please subscribe it and press the bell icon so that you get the notification of the upcoming videos on the time and you could not miss the video. and share this video with your friends and batchmates so that they can also learn about this video lecture.